Today, we are going to introduce the most advanced video segmentation model currently available called SEC. Its performance and results are far superior to our SAM-2 model. Why has this model achieved such a significant breakthrough in the field of image segmentation? The most critical factor is that it shifted from simple feature matching to the understanding of advanced concepts. You could say it possesses certain reasoning capabilities. This is different from the SAM-2 model we discussed. SEC utilizes a large visual language model to understand objects conceptually. It doesn't just look at the object from its appearance, it also tries to understand what the object is from a linguistic perspective. Additionally, it can adapt to very complex scenes, such as camera cuts or objects temporarily vanishing and then reappearing. This model can perfectly track and segment target objects. Having such a model brings us very significant benefits. For instance, if we use character replacement models like OneAnimate, we can break away from the restriction of continuous video. Even if the character to be replaced temporarily disappears, or there are camera cuts, we can perfectly replace the object within the video. Now, we can already use this node within ComfUI. We will use an extension called ComfUI SegNode. What you are seeing now is the GitHub page for this extension. The installation of this extension is relatively straightforward. Firstly, we can install it through the ComfUI manager and then manually download the model. Alternatively, we can perform a manual installation. First, we navigate to the custom node directory, then download the entire repository. We install all dependencies using pip install R requirement in Python. Next is the model download. After downloading, you can place the models inside your ComfUI model.sym folder. Regarding the model download, you can see there are different types. We suggest downloading the FP16 version. If your VRAM is insufficient, that is below 12 GB, you can choose FP8. You can decide which model to download based on your computing power. In addition, before installation, you need to check your basic environment. Python should be 3.10 or higher, but it is not recommended to use version 3.13. PyTorch should be 2.6 or higher, and CUDA should be 11.8 or higher. This should generally be satisfied. I have also built the corresponding workflow on Running Hub. You can access this platform through runninghub.ai. In the ComfUI domain, Running Hub is an excellent online workflow platform because whenever new technology and extensions appear, they track them immediately. You can register for Running Hub using the invitation link in my video description to receive 1,000 free credits. Furthermore, you will receive 100 free points daily just by logging into Running Hub. This allows you to try your own workflows for free. Now, we will detail the usage of this model through 4 examples. Although this model is very advanced, it does not mean it can solve all problems. Therefore, we will use 4 different instances to show you its pros and cons so that you can understand how to use it effectively. Let's look at the first one. Before that, let's briefly analyze the workflow. Here, we first have the video that needs to be segmented. Next, let's look at a very important feature of this model. It can perform forward and backward inference. Therefore, we do not necessarily have to segment the object in the very first frame. You can use any frame in the middle. We are currently looking at the simplest case, segmenting the object from the first frame. So the frame number I selected is frame 0, which is the starting frame. Then I extract this frame from our image sequence. We use a very important node, which we have used more than once. For example, in OneAnimate, where we initially used the point editor to segment our corresponding video image. Look at the first frame. It is very clear. The child is crawling on the ground. But note, the usage here is somewhat different from OneAnimate. Try to use dense points to segment the main subject. In OneAnimate, the density of the points was not required to be so high, so the number of points used in that workflow was relatively small. But here, we use many more points. Similarly, green points represent the part we need to select, while red points represent the part we need to exclude. Once we set these points, we obtain 2 types of coordinates. The positive coordinates, the area where the green points are located, and the negative coordinates, the points we need to exclude, the red area. We can display this to check if your coordinates are accurate. To make it clear for everyone, I will run the workflow now. The workflow has now finished running. Briefly check that no errors occurred, as any error will severely affect the subsequent segmentation. Afterward, we will use our very important node called SE Video Segmentation. Here, we need to load the main model. I use BF16 here. You can keep the overall settings as default. Within this segmentation node, most parameters do not require adjustment. Please pay attention to this area. The tracking direction, since the frame we select might not be the first frame and could be an intermediate frame. Everyone should ideally choose. After that, we can draw the mask onto the image to check. Let's look at the final result. This video has very frequent camera cuts. Look, initially the child is crawling, then jumping onto many pillows. However, an issue arose in this frame. When the child turned head down, the segmentation lost the head. This workflow teaches us that if you use this model, you should pay attention to extreme poses, such as being head down, which can cause the segmentation to be lost or fail. Next, let's look at the second example. The original video for the second example is of a realistic figure and a virtual character performing a concert together. This video was generated by the Sora model, which many people have likely tried, and the results are indeed fantastic. In this case, I did not use the first frame. Look, I used frame 90. The resulting image I obtained is like this, containing both realistic and virtual characters. Then I used dense points to segment out the realistic character, and used red points to exclude the virtual character and the environment. Let's look at the final generated result. You will find that in most situations, the character is segmented. However, there are two situations where segmentation failed. The first is when the person turns their back to us, like in this shot. The second is a close-up shot, like this one. Why is this? It is quite simple. The features of the subject we segmented were primarily full body and facing the front. As the shots change, we can segment similar situations, but if the shot is facing their back, or if it is a close-up shot, you will find that the model fails. Many people might be thinking, if we use the close-up shot as the segmentation frame, would the effect be better? I also attempted this for everyone. I used frame 20, the image you see now, as the segmentation shot. Here we primarily highlighted the face, hair, and hand areas. The clothing and body parts were less represented. If we segment using this approach, let's look at the final result we get. The result is relatively poor. First, there are misjudgments. You will find that sometimes there is segmentation content on the virtual character. Furthermore, the correctly segmented parts we obtained are primarily the face and hands. There is basically no segmented content on the body. Therefore, close-up shots like this are also generally unsuitable for overall segmentation. If it were a half-body shot, the effect might be much better. Next, we will show you a scenario of perfect segmentation. Look at this video. This video shows a man and a woman dancing together. It involves many camera cuts, but you will notice that no matter how the camera cuts, the man is always a full body shot. Therefore, we take the first frame, segment the male subject, and exclude the environment. Let's look at the result. From the start, through the camera cut, the man disappearing and then reappearing, you will find that the overall character is segmented. There are no major problems. Through these few examples, we have demonstrated how you should use this model. You need to pay attention to extreme movements and extreme shots. Next, let's discuss the specific application. Look, this is a modified one-animate workflow. Please note that the video we are replacing has camera cuts. It is not continuous. If I swap the segmentation model with our CC node, I can replace the character with the beautiful woman from my reference image. Let's look at the final result. The effect is superb. This demonstrates that the innovation of a key technological point can bring about many overall improvements in the final result. I will explain this workflow in detail in the next video, how to use it and what points to pay attention to. That is all for today. What are you waiting for? Try it yourself quickly. Follow me to become a person who understands AI.